Next on stage, and for me to introduce, is Erik Visscher. Erik, you're a partner at Vries and Metman. You're also the head of the working group IP and Trade at the European Quantum Industry Consortium. You have a PhD in physics, you studied law in Leiden, and your field of expertise includes physics, electronics, and ICT, and many other things in that dimension. Erik, welcome. The floor is yours.
Thank you very much. Can I control this?
Yes, you want to use the big, this
one. Yeah, okay. Thank you very much. Does that work? Sorry about that. So yes, good afternoon. So my name is Erik Visscher. I'm a patent attorney and an attorney at law, and also head of the working group IP and Trade of QuIC. And I'm not doing this work alone, but I do this work with a team. These are members of QuIC, and I'm leading this working group together with Jérôme Plante-Bordeneuve from Thales. And so I have to mention him explicitly because a lot of data that I will show you is his property. So QuIC has been introduced already quite extensively, so I'm going to skip this one. But very important part is that QuIC has a lot of SMEs, startups and scale-ups, and these companies, they try to get a quantum product on the market, and they face a lot of challenges. So one of the important tasks that we have is we have this intellectual property and trade working group, and we try to help SMEs and companies with IP problems. So that means basically we do an analysis of patent positions globally. We help the SMEs on IP issues generally, obviously. And we also try to interface with the players, so the European Patent Office and also the European Commission. So the important aspect that I want to emphasize here is that there's not only big tech and academics, but we have a lot of SMEs and scale-ups. And some of these scale-ups, they present themselves as the global leaders at the end, and they have to compete on a world scale. So we have very young companies, 3 to 4 years old, over 100 academics or more, and they have to basically compete with especially with companies in the US on a world level. And obviously, when you talk about competition, IP will play a big role in that. So let's take a look at the patent filings. Let's take a look at some data that we have gathered. So these are data of last year. So it's not the most recent one. We're working as we speak. We're working on an update on that. So we will publish a white paper on the IP landscape in quantum end of this year, which is accessible via the website of QuIC. But as in any technology revolution, also in quantum and as in AI, the numbers of filings every year increases, well, not exponentially, but tenths of percentages. So what I show you here is, so in the last years, the number of filings in quantum has grown considerably, and this is the division is here. You can see here the companies that file these applications, and you see that in the US the number of filings, and in China the number of filings are way higher than all the other countries, like in Europe. And you have to know that patent applications are only published 18 months, so 1.5 years after you file it. So if you do statistics on patent filings, you basically do statistics on filings that have been filed 1.5 years ago. So we have to, so since there's a lot of activity, IP activity in the last years, we'll try to update that on a yearly basis. So here you see that in terms of filings, the US is way ahead of all the other regions in that respect. So now let's take a look at the filings per domain. So we have what we did here is we have 3 domains, so quantum computing, sensors, and communications. And then you see that there's also an increase in the filings, and that most of the filings are related to quantum computing technologies and communication and sensors. It's following. So that's all in line with the general trend. But now let's take a look at the main assignees, so the patent owners, the companies that file these applications. So if we take a look at quantum computing, for instance, you see that. So now I've drawn I have illustrated the nationalities of the companies. So you see it's mainly US-based and some Japanese companies that lead the rankings in this case. And so the European-based companies are sort of in the next line, so still way ahead, I would say. Then, interestingly, if you look at quantum communication and crypto, that's where you see there's a different division. Here you see that Japanese and Chinese companies are in the lead, and some US and one US company, and then obviously we also have ID QuanTiQ from Swiss. That's also active in this field. So based on the domain, you see that there are different players active and leading the rankings in patent filings. But again, also I would say the contribution of European-based companies is relatively small. So this is another statistic just for you to show that this is published European patents. So these are patents that are filed in Europe, and you see that is the ranking is led by US-based and companies with some with D-Wave and Fujitsu also and Huawei also in the top rankings. This is and this is also an interesting picture. So this is the last one, the last data that I will show you. But it also sort of illustrates what's going on in terms of filings. So if you only take a look at European companies, so let's say IBM is a US-based company, right? So it's only European-based companies. The organizations that lead the ranking are in fact not companies, but are research organizations. So what you see here is, for instance, that the French research organizations are very active in filing applications in quantum computing, or let's say quantum sensing in this case, and computing. And Robert Bosch, obviously, in the sensing. And then there's in the ranking you have scattered either research organizations and some companies. So that's basically some presentation of data that's interesting you regarding the patent filings in the field of quantum computing. So the main message here is we have a lot of we're leading in the scientific indexes, so the scientific publications we lead, but in the IP filings we are sort of way back behind in terms of numbers. So there is a mismatch here, and what we try to do within the group is we try to advise and educate SMEs and other companies to explain why intellectual property is so important, right? So it's not only to create monopolies, but there's a complete list of all kinds of situations where IP is an important tool that you can use in your daily business. And at the end, especially for investors, IP is really very important, because the first question an investor will ask a startup is, how is your IP position? So when trying to let's go over to patenting quantum technology. So basically, these inventions can be anywhere in the quantum stack. So starting off at a very low level hardware. So that's hardware basically. Patenting hardware. There's no real. It's not really different from patenting any other hardware in other technologies. But if you go up, you see up to the application level. And application level, basically, you're talking about quantum algorithms. And so there's also, when you would like to file, you would like to have protection for applications, you have to file. Basically, you have to file an application that relates to quantum software. So at least software that has a quantum component, so quantum algorithms and stuff like that. If you look at the website of the European Patent Office, there is a division in the types of filings on technology you have. So indeed, there are a lot of filings that relate to quantum simulations of processes and systems and materials, models based on quantum circuits, quantum algorithms, quantum programming or quantum cloud programming, and also quantum neural networks. So there are many filings based on this type of applications. And in that context, it's very important in Europe that you present your application and your algorithm as an algorithm that runs on a hybrid computer system. So it's a classical computer system where you have a sort of a co-processor, which is the quantum part. And in that, if you present your application in such a way so that's running on such a hybrid processor, the success of obtaining protection for such algorithm will increase quite a lot, because in Europe software is patentable as long as it has technical character. So it's a technical. You have to present your invention as a technical solution to a technical problem. And that's basically allowed at the EPO. If you either have an application that is considered technical by the EPO, so in that case, medical field image processing, encryptions, these are considered technical, and then there's no problem at all. But for instance, if you want to have an algorithm that has an application in finance, you'll have a problem, because finance, logistics, and natural language processing is not considered to be a technical, does not have technical character according to the European Patent Office. And there's another box where you can try to argue that an invention is technical in the sense that this software is adapted to the internal function of a computer. Now, with a normal classical computer, that's not always the case, but you have some special cases, like you have a GPU and the software is specifically adapted to running certain parts on a GPU, or you have parallel computing architecture. With quantum computing, you always have a special architecture. So basically, what we feel is that patenting quantum software, quantum algorithms, shouldn't be a problem, because it's intrinsically technical. All the algorithms at the moment are described still on a very low level, like quantum circuits, and where you manipulate basically qubits at gate operations. So these are the typical applications that are filed. So that in my practice, I basically more than 50% I'm dealing with this type of technology. So and yes, at the end, patents in Europe are granted on this type of. So here, this is, for instance, an example. It's a granted European patent that deals with special architecture for quantum annealing. This is, for instance, an example where there you have an quantum algorithm that computes that does quantum phase information estimation based on executing a certain quantum circuits. So yes, you can have protection for this type of mechanisms, and I think that we try to emphasize the SMEs who are not only active in hardware but also in software to look at these, study this, and file for patent protection when needed. Another very interesting development, and also very much related to IP, is that the standardization activities are picking up, as already told. So it's not only standardization within the quantum computing stack. It's also integration of quantum technology in other technologies like telecom. So, for instance, if you look at the map, the roadmap of 6G and beyond, you see that for 6G you have it's completely AI enabled, and also you have quantum computing and quantum communication components. So this is this shows that there is definitely a trend in integration of quantum technology in other standards, and which means also that big players like Xiaomi, Nokia, Ericsson, and all the other telcos will be interested in filing IP on this type of technology. So besides the traditional filers, the companies that are active in developing parts of a quantum computer or a full stack quantum computer, you also have the big telcos that will file IP on this aspects. And it's not something far away. It's really there already. Like, for instance, this is the roadmap for 6G. 6G is completely AI enabled, so there's lots of AI going on in 6G, and that's already foreseen. So they're basically developing the standards, which should be ready in 2027-28. And there's in ETSI you can read about these developments, and they also they standardize basically metrics and schemes for testing these algorithms, these models. And the same thing will follow for quantum, definitely. So it's good to be aware of these processes and to step in as early as possible. So what we do is we keep on monitoring these developments and try to interface with organizations that are working on standardization. So we have a good interface with the QuiC standardization working group in this sense. So last thing, so there's in patenting there is also some external new developments, obviously, which are quite interesting and may impact the filing activities in Europe, because we have the establishment of the European Unified Patent Court and the Unitary Patent, which means that there's now one patent for protecting one patent that is valid in 70 member states, EU member states. Okay, so ongoing activities of our working group is patent information. So white paper on patent landscaping, which follow closely. We'll follow this autumn, I think. We have contacts with the EPO in discussing issues, because also for the European Patent Office, this new technology is difficult, and it's difficult for examiners to understand this technology. So we need to have face-to-face contact with the examiners and trying to understand each other's needs and problems. We monitor the discussion on SEPs, so standard essential patents. That's our patents that read on the standards. And since standardization is also becoming more and more pronounced in quantum computing, we'll monitor that and advise where needed. We try to train the patent professionals, so we have some in-house patent attorneys that are present in the working group. So we try to develop IP best practices. And at the end, I didn't talk about that, but that's another complete field. We also deal with export control, which is also a very challenging problem for SMEs within Europe. But okay, that's for another time, I would say. Thank you very much.